Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York. This is 5th grade math, Module 5, Lesson 5. Today we're going to use multiplication to connect volume as packing with volume as filling. So we're going to kind of relate liquid volume and what we've learned so far about solid volume. So the first part of this lesson had an activity that requires some materials that we don't have available to us right now. So I'm just going to kind of fill that part in with the conclusion on question 4. It says, what conclusion can you draw about 1 cubic centimeter and 1 milliliter? And I'm going to tell you that 1 cubic centimeter and 1 milliliter are the same amount of volume. So 1 cubic centimeter, which is 1 centimeter cubed, equals 1 milliliter. They're going to be the same amount of volume. So with that information, it says the tank shaped like a rectangular prism is filled to the top with water. Will the graduated cylinder hold all the water in the tank? If yes, how much more will the beaker hold? If no, how much more will the tank hold than the beaker? And explain how you know. So this is a multi-part question here. So we know that the volume of our beaker here is 1 liter, which is also 1,000 milliliters. So knowing that 1 cubic centimeter is the same as 1 milliliter, we want to calculate our volume for this prism, how much would fit inside of it. And we want to figure out if it's going to be more than 1,000 centimeters cubed or cubic centimeters, or if it's going to be less than 1,000 cubic centimeters. So first thing I'm going to do is I'll multiply, and I can multiply these in any order, but I'll do 13 times 8 because multiplying by 10 afterward will be easy. So 13 times 8, 3 times 8 is 24. 1 times 8 is 8 plus 2. So it's going to give me 104. And then I just need to add, or I need to multiply that number by 10. So 104 times 10 will give me 1,040. So that's going to be the volume of this, 1,040 cubic centimeters. So will the graduated cylinder hold all the water in the tank? Well, if this holds 1,000 milliliters and this holds 1,040 cubic centimeters, which is also 1,040 milliliters, it will not hold all of the water that's in the tank. So I'm going to say no, it will not. And it says, how much more will the tank hold than the beaker? The tank will hold 40 milliliters more. So the volume of the tank, because it wants us to explain how we know. Volume of the tank is 1,040 centimeters cubed or milliliters. Let's look at number 6. It says a rectangular fish tank measures 26 centimeters by 20 centimeters by 18 centimeters. The tank is filled with water to a depth of 15 centimeters. What is the volume of the water in milliliters? So the tank measures 26 by 20 by 18. And the tank is filled with water to a depth of 15 centimeters. So we're going to assume that 18 is the height here. So I have 26 times 20 times, instead of 18, I'm going to say 15 because the part that's not filled is not so important to us now. We're looking for the volume of the water. So I can multiply these in any order that I want, but I'll do 26 times 20 first. That will give me 500 or 520. Then we're going to have times 15. 26 times 2 would be 52. Times 10 is 520. And then times 15, well, I might need to do that vertically. 500, nope, 520. So 520, 15. That'll give me 7,800 altogether. So we have 7,800 milliliters. Be cubic centimeters, but we also know that cubic centimeters will be the same as milliliters. And then how many liters is that? Well, we know there's 1,000 milliliters in a liter. So I'm going to take that number, that 7,800 or 7,800, and I'm going to move my decimal point back 10, 100, 1,000. Divide by 1,000. It's going to give me 7.8 liters. 7 8/10 liters. Or we could say 7 liters and 800 milliliters. How many more milliliters of water will be needed to fill the tank to the top? Explain how you know. So now we need to multiply 26 times 20 times 18, and then subtract the amount that we have already. The other way we could do it is we know the difference between 15 and 18 is 3 centimeters. So there's only 3 centimeters to the top that's not filled, and we could just find the volume of that part that's not filled with water right now. So instead of doing that, I could take my 520, which I know is my area of the bottom of my fish tank, and then I can multiply by 3. So 520 times 3. 3 centimeters is the empty part of the fish tank. We'll get 1,560. 1,560 milliliters. And I'm going to say this is the area of the bottom of the fish tank. Times multiplied by the remaining 3 centimeters. And just to draw a picture so we can see really what we're doing here. If I had, here's the front of my fish tank here. A little bit further there. All right, so here's my fish tank. And say we're full 15 inches of water here. So I have this whole thing here is 15. This bottom part was 26, I believe. Yep, 26 centimeters. And then this part here, going back, is 20 centimeters. This little piece right in here between the, sorry, this is 18 centimeters altogether. This little piece here is 3 centimeters. And the part with the water in it down here is 15 centimeters. So this is what we figured out the first time. It's up to that water level. I'm going to shade in my water so you can see that that's full. And then the remaining 3 centimeters up here that was not full is how much more water we would need to fill to the top of the tank. So this distance right here. Since we already know that 20 centimeters by 26 centimeters gives us 520, we can just multiply by the remaining 3 centimeters to the top and find out the volume of that empty area right there. So that's all we did there with the 520 times 3. All right. So lastly, number 7 here, it says a rectangular container is 25 centimeters long and 20 centimeters wide. If it holds 1 liter of water when full, what is the height? So now we have a missing side question here, or missing dimension. I'm going to draw a pretty similar looking prism here. All right, so I have my prism here. And my width here, my length is 25 centimeters. This direction here is 20 centimeters. And we know that the volume is 1,000 milliliters, or 1,000 centimeters squared, or cubed, 1,000 cubic centimeters. So if I have 1,000 cubic centimeters, and I know that my area of one of my surfaces, the bottom of this tank, or the bottom of this container, is going to be 25 times 20, which is 500. I just need to divide by 500 centimeters squared, or 500 square centimeters. It'll give me my remaining side. Well, 1,000 divided by 500, that's half of 500, so it's gonna give me 2. And now I know that this height is 2 cubic centimeters. So I was trying to figure out what this remaining side was. I take the product of these other two here, and I divide the product, or I divide the volume by the product. And I'll get 2 centimeters cubed. All right, so that's all the time we have for today. Thank you guys so much for tuning in, and I look forward to seeing you next time.